and then some possible examples of how these tokens can be used. Okay, so when we're talking about auth-n versus auth-z, authentication is to verify the identity of who you are, right? So making sure that you are who you say you are and that you're not impersonating someone else or pretending to be someone else. Whereas authorization is to verify that you have the proper permission or access to perform this action. It doesn't really matter who you are, it's just that are you allowed to do this thing, right? So if we distinguish those two, one is to just make sure you are who you say you are, and the other one is to make sure that you can actually do the thing that you're trying to do. So an example is flying on a plane. When you want to fly on a plane, you have to provide a passport, and the passport has your photo, and it's used to identify you. So it's to make sure that you are who you say you are. But having a passport on its own doesn't actually get you anything at the airport. All it does is get you through security. You verified who you are. In order to be able to perform an action like get on the plane, you need a plane ticket. So the plane ticket itself authorizes you to board that plane, but the passport identifies you as the person. Okay, so another example is like riding the bus. So when you ride the bus, you go to the transit station and you buy a transit ticket, right, like this. Now, when I buy this ticket, it authorizes me to ride Calgary Transit for 90 minutes. When I get onto the bus, I present the ticket to the bus driver, and the bus driver just has to check the time and make sure that it hasn't expired yet. They don't actually care who I am. I don't have to prove my identity or anything like that. This authorizes me to get onto the bus. This is the token. This is the bus token. So now if I were to transfer this token to Syed, or if I left it on my desk and Syed were to take the token and then go enter the bus, he would be allowed to get onto the bus. There's nothing that says that this token belongs to me and that can only be utilized by me. It belongs to the ticket holder. So whoever has the ticket can then use the ticket to gain access to whatever resource is required or that is allowed for that ticket holder. So that's important in terms of distinguishing between authorization and authentication. You're not supposed to transfer your ticket, but if someone steals my ticket, I have no way to tell Calgary Transit, hey, my ticket's been stolen. Do not honor this ticket. Do not let Syed or whomever stole my ticket use this ticket. Okay, so now there's two different types of tokens. Bear with me, I haven't actually rehearsed this presentation, so I'm just doing this on the fly, so I'm going to read a little bit off the board. There's the access token, which is used, would be the equivalent of the actual transit ticket that you use to actually get onto the bus. This gives me access to the resource. And then there's a refresh token. So a refresh token would be something that I can use to exchange for a new access token or a refresh token. So the purpose of the token is to allow clients to access a protected resource scoped to the privileges defined by the token in the scope. So the access token represents a subject, an audience, an issuer, and an expiration. So in the example of Calgary Transit, the subject is the ticket bearer, right? So whoever's holding the ticket is the person who gets to use it. The intended audience is the bus driver. That's who you're supposed to present the ticket to. And the issuer of the ticket was Calgary Transit. That's who I purchased the ticket from. Now, it expires in 90 minutes from the time the ticket was issued, but it authorizes me to use Calgary Transit during that time, that 90 minutes. We're going to come back and talk about refresh tokens, but I'm going to wait a little bit. I want to talk about the different types of tokens first. So there's different types of tokens. There's the stateful and stateless. So a stateful token is one where you actually have to do like some sort of lookup to verify that the token exists somewhere else, usually like in a database in order to honor it. Whereas a stateless token is a token that has all the information necessary encoded in the token itself. You don't have to do any lookup to be able to verify whether that token is usable. So in that sense, all the state is in itself, so that's what makes it stateless. You don't have to store the state elsewhere. So an example of a stateful ticket. So when you go to a concert, usually you have like a barcode on your ticket. I didn't bring a concert ticket with me, but you have a barcode on a ticket when you go to enter the venue and they will scan the ticket. And usually that barcode is linked to some back-end database to see whether or not it's been used before, right? So that's an example of a stateful token where they have to do a lookup somewhere to see, has this ticket been used? Is this a legitimate ticket, etc. And once it's used, it cannot be reused for that event. An example of the stateless token, we've already talked about one, which was like the Calgary Transit token. All the information necessary to access the resource is encoded in the token itself. So I can present it to the driver and it gives me access. So it doesn't, the driver doesn't have to like look up in some database somewhere or scan it to verify that the token is valid. There's a couple of different formats that we can use to, okay, so coming back to like the technical world, there's a few different ways we can represent a stateless token. The most common one seems to be the JWT, the JSON Web Token, where in the JSON Web Token, it describes a format that we can describe a token that has all the information necessary to, to perform the authorization. JWTs are broken down into 3 segments. So if you look at a JWT, you'll notice you can tell a token is a JWT most of the time by just finding the 2 dots in the middle. So it's delimited by a period. It starts with a header, a body, and then a signature. So we look at an example of one. It'll look something like this. I had to snip a bit of it to just condense it, but it'll look like base64 encoded text, period, base64 encoded text, period, base64 encoded text. And so what you're looking at is a header, body, and a signature. Now, if we unpack that, if we just look at the header has a standard format that describes, here's the algorithm, in this case, of how to verify the signature. So we're using RSA, SHA-256, there's like public-private key pair to verify the signature, which is the last section in the JWT, which I didn't include here. And then in the body, we can see some claims. And this is the actual JSON Web Token itself. It was base64 encoded, but you can see all the claims right there. It's not encrypted. It's free to see. So there's nothing secure in here. It tells you things like the expiration. So EXP, I didn't make this up. If we go look at the JWT RFC, these are the names in the standard itself. So EXP describes, here's the Unix timestamp of when this token expires. IAT is the issued at, which tells us this is the time that this token was issued. The issuer tells us who issued the token. In this case, we use the Shiro entity ID, which is a SAML entity ID, to describe here was the issuer, so the ID is sort of the same. NBF is the not before time, so that tells us that this token cannot be used before this time, which means that we can actually issue tokens before they're actually allowed to be used. So if you wanted to make sure that a token can only be used one token per month, you can actually issue all 12 tokens now and just have them start and end at the appropriate times. JTI is the unique identifier for the token itself. So if they did want to do something like revoke a token, we can record the JTI and say, like, in case anybody wants to see if this token is still live or has been revoked, the identifier can be used for that. And in our case, the subject is the UUID of the user. So we have a UUID that we use to represent each user that cascades across systems. So when we're talking about UUID D98, we're talking about the same user that exists in Portal, Shiro, Castle, etc. That is the identifier that is sort of global, that's meant to be persistent and not change. Okay, now let's rewind. I sort of skipped refresh token, but let's talk about refresh tokens. So I mentioned earlier that the purpose of the refresh token is to get you a new access token. And we know that access tokens can expire. So when an access token expires, we need some sort of mechanism to get a new access token. So like after I did my 90-minute trip on the bus, well, I still need to get home. So I need to somehow get another ticket so that I can perform that action of getting back on the bus. So in that analogy, the example that I'm providing here is a credit card, where it's not a clear, like a really good example, but if I want to get back onto the bus this afternoon, I can go get a new access token or a new bus token by purchasing a new card with my credit card. Now, in that example, it's a little bit weird because when you get a new access token, the person providing you the access token can also provide you another refresh token so that you can get a new token in the future. It's optional. So in this case, Calgary Transit unfortunately won't provide me with a credit card when I buy transit. So it's a leaky example, but it's up to them to decide if they want to include a refresh token. But the purpose of the refresh token is to give you an entry point to get a new token. Okay, so now let's talk about the, so are there any questions? Good. Okay, good. Now let's talk about roles. So these are the different roles in an OAuth 2.0 workflow. So if you look at the RFC, this is what they define. Client, a resource owner, a resource server, and an authorization server. So when we say a client, we're actually talking about either it could be your service, it could be a web app, it could be a single page application, it could be a mobile application. It's something that wants to perform an action on behalf of a human, the resource owner, right? So the resource owner in most cases is going to be a person. So the client wants to get data on behalf of person X from this API, but the client resource owner doesn't necessarily want to give the client its username and password to do that. It very well could, but then If that username and password gets compromised, the user has to go change it. So we decouple it by using tokens. Now with the resource server, this is the actual destination API that the client wants to talk to get data on behalf of the resource owner. And the authorization server, in some cases, can actually be both. You may end up having the authorization server and the resource server being the same thing, but the authorization server would be the equivalent of the person that's actually issuing the tokens and can verify and validate that the tokens were issued from them. Oh no. There we go. Okay, so this is the protocol flow directly from the RFC. I linked all the RFCs in my final slide, so it'll be there. But here's how things typically work. So you've got a resource owner, which we know is the human, as Jonathan says, and we've got a client who wants to access data on behalf of the human. So what the client will do is say, okay, I'm going to send I'd like to perform like an authorization request with the human to say, I'm going to give them an opportunity to say, yes, I give this client an opportunity to access data on my behalf. So this is called a grant, or an authorization request, and then the user or human would return a grant. So there's several different types of grants. So this is I'm going to talk about a few different grants in a few upcoming slides. But the process here is the client is requesting that from the user that, hey, can you give me something just to say that I can prove that you're giving me access to pull data on your behalf, and that's called the grant. So once the client has received a grant from the resource owner, the client can then exchange that grant with the authorization server to get an access token, right? And that was the token that gives us access to get onto the bus. That's ultimately what the client wants. The client doesn't care about the grant. It's just what the client uses to prove that it's allowed to get a token to perform an action on behalf of the user. So once the client has the token, it can now access the resource server. So it can start making API calls to that resource server on behalf of that user and start receiving and fetching and performing actions on behalf of that user. So what we've done is we've decoupled the resource owner's username, password, credentials with a token that's scoped to a limited amount of time with a limited amount of permission, right? So we've decreased the exposure of that resource owner, but we're still allowing it to use a client that can actually perform actions on its behalf for its benefit, but without compromising the resource owner or limiting the amount of time and surface area for that compromise. Okay. Well, I forget what the slide is. There's a delegation protocol. The client does not know the credentials of the resource. Oh, I just said that. Yeah, the client doesn't know the credentials of the resource owner, but can access resources on its behalf. So in our example here, the resource owner is the human. My app is the client. Auth.amp.cisco.com is the authorization server, and api.amp.cisco.com could be the protected resource, or it could be the SCIM API, which happens to also be in Auth. Okay, so I'm going to skip this, but this is something that we provided as a short circuit for making it easier to get the initial token, because getting the grant requires additional work on the client. To make it easier and to make it easier for clients to actually start using our APIs, we short circuit this by including an access token in the SAML response. So that reduces the need to do the upfront grant, or fetching a grant and then exchanging it for a token. So this is a short circuit we did for convenience to make it easier to use the APIs. I don't know if it's actually working. Okay. Now let's expand this into an actual workflow here. So client goes and redirects the user, the human's browser, to the authorization server. So this would be a page on GitHub where you're saying, I'd like to authorize Travis CI to access my GitHub public profile, right? If you've ever seen that page, that is an example of a grant, an authorization grant, where you're granting Travis CI, the client, to access data from the GitHub API on your behalf. And so at that point, the user then says, okay, yes, I accept, and the authorization server generates the grant and returns the, this is a different part. This is the part where we're actually exchanging the grant. Okay, so once the client has a grant, it exchanges a grant with the authorization server. Authorization server says, hey, did I issue this grant? Is this a real grant? It is. Okay, you can have a token. So you get an access token and a refresh token. You hang on to the refresh token, you put that in your wallet, 'cause that's where you keep your credit cards. and you put your access token in your front pocket so it's easy to access when you want to go ride the bus. And then with that, you make a bunch of API calls with the access token, and you get your protected resource. And you sort of cycle back and forth making API calls for a little while until all of a sudden you get an invalid token error. And that invalid token error usually means that your token has expired or has been revoked for whatever reason. You don't know the reason because the token may have been compromised, someone may have listed it as revoked. All you know is that token's no longer valid, right? And so now it's up to you to go and pull out your credit card from your back wallet and exchange your refresh token for a new access token. And the cycle continues. Now with that access token, you can start accessing the protected resource over and over again. So we can see that there's several cycles in terms of tokens. The token life cycle is limited, and it's meant to be rotated often. They're meant to be short-lived. Yes, in the back.
So on the second access token and optional refresh token,
yep.
And the first time you get the access token, do they have to provide a refresh token?
They do not have to, but
okay, so it's still optional.
It's still optional. I believe it's still optional. We can look at the RFC, but I believe it's still optional. And the reason is they may not want to support the refresh token grant. They may not want to allow you to exchange, in this case, pay for with a credit card. Maybe they want you to go generate a
restart the whole.
Yeah, restart the whole process of going through the grant again.
Okay.
Okay, so there's a few different types of grants. The most common one was the authorization code grant that's used for web apps. So the example I provided of seeing a web page where GitHub's asking you, do you authorize Travis CI to hold data on your behalf? That page is an example of an authorization code. If you look at the URL and just follow the network traffic, you'll find that an authorization code parameter is actually posted back to Travis CI, and Travis CI will then take that authorization code and use that and exchange it for a set of tokens. Next one is the implicit grant. The implicit grant is meant more for JavaScript applications, so single page applications where you do not want the token to ever hit a server. So the client-side application will redirect to the browser, and then the browser will redirect back to the client-side application using a fragment parameter. So if you look at any URL and you add the hash plus blah, everything after that fragment does not end up going to the server. So it's just a convention that the user agents use, and so that's how the code is transmitted to the single-page app. Password credentials allows you to actually take a username and password and exchange it directly for a token. So in this example, they say trusted clients. That would be okay, the Twitter application, the mobile app, wants to access the Twitter API. Well, that would be considered a trusted client because it's built by Twitter. So they're saying that, yeah, I'm going to let the Twitter client use the password credentials grant. So the user can enter their credentials directly into the Twitter app, and then the Twitter app can exchange those directly for a token. Client credentials grant, this is more for OAuth client applications. I'm not really going to talk too much. We talked about the client can actually receive a token on behalf of the user. The client itself can actually have its own client ID and client secret, and it can use that to exchange tokens for itself, not really for a user. Refresh token grant we talked about, where you take a refresh token and exchange it for an access token. And then there's extensions to grants. You can build your own grant types, some extensions, all the SAML bearer and JWT bearer. So if you have a SAML assertion, using the SAML assertion, you can actually exchange that SAML assertion using the SAML bearer grant and get a token back. So that's another short circuit. Okay, where am I for time? 11:53, we have a delicious food coming. Okay, grant types, authorization code, we talked about that. So I'm going to kind of fast forward here. Okay, so this is an example of that GitHub Travis UI workflow, where the human uses a browser, which is a user agent, redirects to the authorization server, user authenticates on the authorization server, then says, clicks the button, yeah, I authorize. The code goes back to the user agent then transmits that to the server. In this case, it's a web application, not a client-side application. Client then takes the authorization code, exchanges it with the authorization server. It has to provide both the code and the redirection URI, because if the redirection URI isn't registered, you could potentially end up leaking the access token to some other endpoint. Oh, okay, and then the client gets an access token. What are we doing here? I've already talked about this many times now, I think, where let's say this is github.com, OAuth authorize. This is the response code, client ID, redirect URI, and then the possible scopes. scopes imply, like, here are the fine-grained permissions that I'm authorizing this token or this client to have with this request. So you don't have to give them, like, pseudo permissions where they can go all of a sudden alter all my Git repos, change my username, change my password, and do whatever you want. I don't want it to have that level of access. I just want Travis CI to be able to read my public and maybe my private repos, and that's how scopes are used to control, like, the access that client has. Okay, so would you like to find, here's the example. So I gave you the visual, now here's, so you're clicking, do you want to give client X the skim read, or read skim me and the write skim me permission? Okay. Authorization code goes back. Client gets the authorization code. Client then takes the authorization code and exchanges it with the OAuth tokens endpoint. Say, here's my authorization, or here's the grant type, authorization code, and here's the actual code. Here's my credentials for authenticating against the API, and then the authorization server will return the actual access token and refresh token in a scheme that looks similar to this. So it tells you in the response that the token expires in 3,600 seconds, but depending on your token format, you may already have that encoded in the token itself, and JWT handles that. This grant type can use a client exchange refresh token for a new access token. Already kind of gone through this. And refresh token, okay, now this is the example where my token is expired, and I want to exchange my refresh token. You can see the payload's more or less the same, except now we're saying that the grant type is a refresh token, and the actual value is a refresh token. And now you're passing the refresh token to the server. Server says, oh, okay, you can have a new refresh token, and here's a new access token. Your old refresh token is expired, but you may use this to, again, gain access to the server. And then now once you've actually got the token, you can make an API call to the API or the resource server using that token. So with JWT, these are bearer tokens. So again, the person holding or the bearer of the token gets to utilize the token, hence the name bearer. So in this case, you access a protected resource, and you get your protected resource data back on behalf of the user. You're able to access data. Simple enough, right? And now we can dance, because we got the data we wanted. So this was a couple of examples. I don't think this is important anymore, of like how to register a token and then continue to activate them. Oh yeah, so the example here was just creating a rake task to do the initial seed. So go register your token. Once you've got your token, you could have a cron job or something that just does automated renewals. So you can like preempt the expiry by renewing it often. So you could, if you know that your token expires in a month, then you can renew it every 15 days and then just keep that cycle going. So you want this to be a repetitive process. Other examples, oh yeah, here's the example of an actual token exchange where we get the new token, we exchange the token, destroy the old token, create the new token, and the new access token and the new refresh token. I guess this is more important for people implementing the authorization server rather than clients. Another way to store tokens and have them automatically rotated is to use a product like AWS Secrets Manager, which we were looking at in the past. You can have like Lambda functions that would be the equivalent of a cron that's running on a regular basis to generate new tokens, rather than having to do it in the application code. You just have your application code should just have the latest token to use, and some other processes sort of rotating them on your behalf. And that's it. An access token decouples a resource owner's credentials from the authorization that it is delegating to a client. So another way to say that, a client is allowed to use an app and giving that app access to specific resources on an API that it's willing to share without having to give up its username and password. And then in the future, if it decides, hey, I don't want to use Travis CI anymore, I can go delete that client, and that client, any tokens that were issued to it would become invalid. So it protects the user. I think that's all I got. These are my references.
Nice.
Great.
Yeah. Ta-da!
You finish on time.
Whew.
What food is not on time?